AP Style Free Response Problem 6. At 40 degrees Celsius, aqueous H2O2 will decompose according to this reaction, where we produce 2H2O and O2. The data was collected for the concentration of H2O2 versus time. So you can see time and concentration. Calculate the average rate of decomposition of H2O2 between 0 and 2.16 times 10 to the 4 seconds. B, use this rate to calculate the average production of O2 during that time. And C, what are those rates from 2.16 times 10 to the 4th to 4.32 times 10 to the 4th seconds. Part A, calculate the average rate of decomposition of H2O2 between time 0 and this time here, 2.16 times 10 to the 4th. So the rate is just the change in concentration with respect to time. So I have the change in concentration 0.5 minus 1 over the change in time 2.16 times 10 to the 4th minus 0. And then remember that it's the rate of disappearance, which is why we have this negative, because the concentration is decreasing. But the absolute value of the rate, 2.31 times 10 to the minus 5 molarity per second. Use the rate in part A to calculate the average rate of production of O2 gas during that same time period. Stoichiometry dictates that O2 will be created at half the rate that H2O is consumed. For every 2 moles consumed, only 1 mole of oxygen is produced. So the rate of production of O2 is half the rate of production of H2O2, or 1/2 the rate found in part A, which leads us to 1.16 times 10 to the minus 5 molarity per second. All right, so what are the rates of disappearance of H2O2 and appearance of O2 for this second time period from 2.16 times 10 to the 4th to 4.32 times 10 to the 4th? So the change in molarity from here to here is 0.250, which is half as much as it was from here to here when it was 0.5. So, and the time period is the same. This is another 2.16 times 10 to the 4th seconds. So both rates would be half what they were. We can confirm this by simply repeating the calculation. So this is the same setup as on the previous part, but we're just calculating a different change. So from 0.25 initial minus 0.25 final minus 0.5 initial, 4.32 times 10 to the 4th minus 2.16 times 10 to the 4th is our change in time. We get a rate of disappearance. Of course, that's what that negative means, right? Of H2O2 of 1.16 times 10 to the 5th. And the rate of appearance of O2 would be half that, given the 2-to-1 stoichiometric ratio. So half of 1.16 times 10 to the minus 5 is 5.79 times 10 to the minus 6 molarity per second.